Okay. Today we're gonna presenting our work, Elementor, an embodied chemistry learning game using mixed reality and generative artificial intelligence. The rapid advancement of media technology has transformed the way people learn. Within this shift, game-based learning has emerged as a scientifically proven approach for enhancing students' comprehension. However, this learning method is still in its infancy in mixed reality environment. Specifically, in chemistry education that we want to discuss, there are few attempts using MR to bridge abstract knowledge and interactive experience. MR aligns closely with the concept of embodied learning by creating situated experience that transform intangible concepts into perceivable entities. Embodied learning involves that human body is essential to cognitive processing, and engaging multiple bodily senses reduce cognitive load while fostering self-exploration. Despite these benefits, current MR education tools often lack the adaptive and personalized support necessary to cater to individual learning paces. To address the identified gaps, we developed Elementor, a serious game for chemistry learning based on fantasy worldview and anthropomorphism. We combine multiple embodied stimuli in MR environment, including visual information and real-world information. We employ LoRA models to create distinctive representations for chemical elements and LLMs for context-aware dialogue and animation. To inform our system design, we conduct a formative study. The study revealed beginners struggle with learning microscopic concepts, teachers' multimodal strategy to help memory recall such as structured visualization, and lack of interactivity in outdated multimedia tools. Based on these insights, we propose a design framework. First, establishing scientifically grounded mapping under professional guidance. Second, utilizing AI to manage structured MR concepts. And third, enabling interactivity at each stage through real-time AI communication.
Hi, I'm Chen. This diagram shows the core user experience flow of Elementor, which will be discussed further using real footage later. You can see 5 snapshots from a real game session here. When the game starts, the player reads a short narrative introduction, a story that sets the stage before any chemistry formula appears. In this example, the player learns that the hydrogen ice squad and the oxygen envoy squad are seeking to form a peace alliance. Next, the player physically walks around the room to find and pick up the elemental characters they need, the hydrogens and the oxygens. Then they bring each group to the forming zone to create hydrogen gas and oxygen gas. After that, the player guides both compound groups to the reaction platform and adjusts the coefficient, and attempts to trigger the reaction. The reaction fires, the animation is played, and the peace squad is formed. The user can proceed to the next level using the book. So here is a detailed gameplay video that I will play for you.
In this video, we present the core gameplay user journey of Elementor. As a part of our paper, Elementor, an embodied chemistry learning game using mixed reality and generative artificial intelligence. The core gameplay user journey is shown in this flow diagram. To complete a level, a specific chemistry formula is given to the user, who then begins by guiding elemental characters from the element mountain and placing them into the forming zone to synthesize compounds. For single-element reactants, the user can directly guide the character and place it into the reaction platform slot. The user then guides the character or character group onto the reaction platform and adjusts the coefficient to match the intended chemistry formula. If the compounds and the coefficient are both right, the level is completed, and the success animation is played. Elementor runs on a MetaQuest 3 headset and is developed using Unity. When the game starts, the user reads the basic premise of the game via a dialog box. The element mountain is the source of all elemental character in this game. The user can greet the character standing in element mountain, who will in turn respond with a brief characteristic dialogue. Following the given chemistry formula, the user guides elemental characters from the mountain and places them into the forming zone. The user can then attempt to synthesize compounds by pressing the button near the forming zone. At this stage, the user places the elemental character group onto the reaction platform. The user can adjust the coefficient of each reactant. If reactants and their coefficient are both right, the success animation is played. The user can proceed to the next level by interacting with the book. New reaction platform will spawn at a different location.
我是心，守护金属宝，虽不参与亲养之约，依然默默守护。
The palm menu displays the current formula at all times for convenient access.
嗨，我是活泼的轻小精灵，与你一起创造水的奇迹。
On the hardware side, Elementor runs on a MetaQuest 3, leveraging in its pass-through feature to seamlessly bend the virtual elemental characters into the player's physical room. The system is built with Unity 2022 and Meta SDK version 77. For the AI layer, specifically the LLM, we use ChatGPT 4.0 to power the dynamic LoRA generation and the context-aware dialogue. For the detailed prompts, please refer to the supplemental materials. Now, one of the biggest visual challenges in Elementor was making each chemical element look distinct, consistent, and thematically meaningful. We solved this with a custom LoRA model. On the data side, we collected costume and character images from Visual Studio and resized them for training. We used the Flux.1 dev model for the base model. After training, we used test prompts to validate the model could generate characters that were visually consistent with the game aesthetic and while reflecting each element's unique chemical properties. The final characters were deployed into the MR environment through Unity. For voice, each character speaks through Doubao Seed version 1.1 text-to-speech model with the vocal tones tuned to match the personality of each element. For example, metal elements tends to sound like a male with a heavier tone. Our study had two objectives. One was straightforward, to assess the effectiveness of Elementor. For objective 2, we wanted to understand what factors influence embodied learning outcomes in this kind of MR games environment, so the insights could inform future designs beyond Elementor itself. To address this, we used a mixed methods approach. For knowledge, we ran pre and post tests before and after the game session. For learning experience, we used two validated scales, the IPQ to measure sense of presence and the IMN to measure intrinsic motivation. And to go beyond numbers, we conducted semi-structured interviews to capture participants' reflective feedback in their own words. The results from the 28 participant user study support Elementor's efficacy. Looking at the bar chart on the left, across all chemistry knowledge categories, post-test scores consistently exceeded pre-test scores. The most striking gains come in compound knowledge. The overall total score rose from 15.75 to 18.61. Gains were observed across every category: element, quantity, condition, and reaction. On the right, we have the experience ratings. The IPQ presence scores, especially general presence and special presence, skew strongly toward agree and strongly agree, confirming that the participants really felt immersed in the MR environment. On the MI side, interest, enjoyment, perceived competence, and the perceived choice all rated highly, and the pressure tension rated very low, meaning participants were engaged and motivated without feeling stressed or overwhelmed. Our qualitative analysis has some insights too. First, participants repeatedly walked up to the element mountain, picked up characters, and carried them to the forming zone or the reaction platform. That physical repetition left real memory traces. Second, some participants found the anthropomorphic character personalities highly engaging and memorable. Others felt that the visual complexity was a bit too distracting. Third, some in-game feedback animations were too subtle or too brief to register, particularly during fast-paced reactions. Fourth, because virtual characters were anchored to fixed locations in the physical room, learners naturally built a spatial mental map. One participant told us their deepest memory was the auction atoms at the top of the hill. The pie chart here shows feedback of effective embodied design in the game based on mention frequency of each type and the scores of effectiveness. Visual factors were mentioned most frequently, which makes sense given the character-rich ML environment. However, interestingly, read-write factors received the highest effectiveness score out of 5.25 out of 7, followed by visual at 4.35. These suggest that while immersive visual capture attention, structured textual information like the narrative lore may be what actually drives retention. On limitation and future work. On UX, hand gesture interactions still need work. Some users found them too imprecise and frustrating, and maybe more dramatic visual feedback so players can clearly see the result of their actions. On content, right now, Elementor covers a limited set of chemical reactions. We plan to scale up that element library significantly, and we want to maybe introduce shelf designs instead of the mountain right now to further leverage spatial memory. On the research side, we want to go deeper on two fronts. First, quantifying exactly how repetitive kinetic actions contribute to long-term retention, ideally through longitudinal studies. Second, systematically matching BARK learning styles to specific sensory stimuli in the game so the system can adapt to different types of learners. Finally, on limitations, our study had 28 university-level participants, which is a reasonable starting point, but not large enough to generalize broadly. Future work will specifically target secondary school beginners, learners with minimal prior chemistry knowledge. Thank you so much for watching.